Welcome back. So we now know about rotators and how rotators are kind of like vectors. They have three values, but they're different. Those values represent rotations about the axes. And we know that a rotator is composed of a yaw, a pitch, and a roll. So let's take a look at this drone here. If I want to change its yaw, I can rotate it about its own z-axis here. Rotating it so it's looking around from left to right like it's about to cross the street, that's changing its yaw, right? And we can rotate it about its own y-axis, and that's going to make it look up and down like it's nodding. It's saying yes. That is changing its pitch. And we can tilt its head like it's looking at you a little funny. It's like, what are you doing over there? This is rotating about its forward vector, its x-axis. That's changing its roll. And it looks like it's rolling. If it's moving through the air and it's rolling, that's what it's going to look like. It's tilting around. We're changing its roll. Now, we know how to add an actor world offset. We can also add an actor world rotation as well. So this is my drone 2. I'm going to go back to my level blueprint, and instead of adding a world offset, I'd like to add a world rotation. So I'm going to go ahead and remove the nodes where I'm adding the actor world offset. This is for drone 2. We're still adding the offset for drone 1, but now drone 2 is just going to sit there all by its lonesome as its friend goes away and chases a shiny thing, right? We're going to take drone 2. I can just duplicate it from over here, and I'm going to add an actor world rotation. I'm going to drag off of it and type add actor world and choose rotation. Now notice that this is kind of like add actor world offset, except it takes a delta rotation instead of a delta location. So we can change its rotation, and if we're doing this in tick, we'll be doing it every frame. So let's see what that looks like. Now, rotators have yaw, pitch, and roll, right? Well, it says X, Y, and Z, and it can be hard to remember which one is which, but if you hover over X, we see that that's the roll value. If we hover over Y, we see that's the pitch value, and Z is the yaw value. Yaw because it's rotating about the Z-axis, pitch because it's rotating about the y-axis, and roll because it's rotating about the x-axis. So every frame, let's add some rotation to, let's say, the yaw. Now I want to scale the amount that I'm rotating about the yaw by delta seconds. So how can I do that? Well, if we don't want to pass in just a rotator value, we can pass in a single float value for each individual component of the rotation by right-clicking on the input pin and choosing Split Struct Pin. And now we have a new version of Add Actor World Rotation that doesn't take in a rotator, it takes in 3 scalar values. One for roll, one for pitch, one for yaw. And we can pass in a value. Well, I'd like to use Get World Delta Seconds because I'm going to scale this amount by delta time so we have frame rate independence. And I'm going to take Get World Delta Seconds and I'm going to use a multiply node and multiply this by the amount that I'd like to rotate every second. Let's say I'd like to rotate 360 degrees every single second. So I'm going to put a 360 in here, and that's going to hook into my yaw. So we're adding a world rotation to drone 2, and we're adding the exact amount every frame necessary to rotate it by 360 degrees every second. And it's frame rate independent because we're scaling it by delta seconds. So let's see how this looks. And there it is. It's rotating, and we're changing the yaw only. So it's rotating around like so. Perfect. Now it looks like I tilted it off axis a little bit here, so I can go back into the details panel for this actor and find its rotation and hit that little curved arrow to zero out that rotation. Of course, that's going to give it a rotation of 0, 0, 0, and this is what it looks like. It's pointing that way. But if I press play, every frame we're rotating it around. So that's how we can add an actor world rotation. Now that's how we add a world rotation. But why isn't this node called simply add actor rotation? Why is it called world rotation? Well, we know that there's a difference between world space and local space for any given actor. And an actor has its own components, right? So let's see the difference between world rotation and local rotation. I'm going to delete add actor world rotation, and I'm going to drag off of drone 2 and type add rotation. And now we can see that there's a lot of options here. And some of these say local rotation, and they even have something else in parentheses. Those things in parentheses, those are the components that belong to the actor. Because when we're talking about local space, we're talking about individual components of the actor. We can add a local rotation to an actor, specifying which of its components should rotate. For example, if we choose scene, well, now we have add local rotation, but add local rotation doesn't operate on an actor. It operates on a specific component on that actor. So simply getting add local rotation with that scene in parentheses is going to automatically get that scene component that belongs to our drone 2. And if we go back to our BP drone and click on its viewport, we see that we have a mesh here, right? But remember, our mesh, which is called drone mesh, is not the root component. It's attached to the root component. The root component itself is our scene component. It's invisible. We can't see it, but that's what's behaving as the root component. And if we're adding a local rotation to the root component, that's going to rotate the root component and anything that's attached to the root component. So let's see what happens if we go ahead and hook up add local rotation and we add the same amount every frame to its yaw. Let's split that struct pin and we'll hook this value in for the yaw and we'll play test. We'll see that we get the same result because we're rotating the scene component and the mesh component, that drone mesh, is attached to it. So it's going to rotate along with it. So basically we got the same result as add actor world rotation. In fact, the truth is add actor world rotation is operating on the root component. So whatever is the root component, that's what these add world offset and rotation functions are operating on. Add actor world offset is going to add that offset to the root component, and everything else that's attached to it moves along with it. We can really see this in action if we take our drone and we offset the mesh from the root. In other words, one way to do that is to go into the BP drone and select the drone mesh and offset it like this. And so now it has this offset from the root. And if we go back to our level and we press play, well, check this out. We're drawing that debug coordinate system at the center of the actor, at the root location, but that mesh is offset from the root, but it's still attached. So even though it's not in the center, it's rotating along with the root component, but the root component is what's spinning. The mesh is just attached to it and spinning while maintaining its offset. Now, I don't want my drones offset like that. I'm going to go back to my drone mesh, and in my details panel, I'm going to take its location here and zero that out by using the curved arrow. So it's now back where it belongs, and we can prove that by play testing. We see that the drone is sitting right there at the scene component location. That's the root. And I did this because I don't want that offset in my blueprint class. That means every single one of these drones would have that offset on it. But let's say I'd like that offset to be on this particular instance in my level. Well, I can do that by coming over to its details panel. I'm going to drag it up here so we can see that under details, there's this section. Now, if you don't see it, you might need to find this line and drag it down. And this section here shows us that BP Drone 2 has components, and we can select those components on this instance in our level. We can select the scene component, that's the root. And if we move it around, we're just moving the actor around because the actor's location is actually the location of the scene component itself. But we can actually select the drone mesh component on this instance. And we can move that forward a little bit. And if we do that, well, we just moved our drone mesh away from its root component, away from the scene component. We've added an offset to it. We can prove that by pressing play, and we can see that it's now kind of stuck out away from the scene component. And this is a very important detail that you have to be aware of. If you've selected an actor and you went into the details panel for that instance of the actor and you selected one of the components and you moved it around, you have to be aware that you're not moving the actor itself, you're not moving its root component, you're now moving one of its components relative to the root, and that can cause bugs if you're not doing that intentionally. But for this actor, that's what I wanted. I wanted my mesh to be offset from the root component, and that's so that we can see that when we're adding a rotation to that root component, the scene component, the mesh will rotate along with it. And we can add local rotations to individual components. We just happen to be using the scene component here, but what if we're adding a local rotation to that mesh component instead? We can get that mesh component from Drone 2 because we have access to it by this actor reference. We can drag off of it, and we can search for the drone mesh. Now, there's a lot of functions that can be applied to the drone mesh, and they'll all pop up here, but we can scroll all the way down to the bottom, and we can use a get node for the drone mesh. And this drone mesh node is a reference to the drone mesh component here on BP drone. So now that we have access to that, we can hook that in for the target instead of the scene component. We don't want them both hooked in because add local rotation will operate on however many things we plug in here. So that may not be what we want. We might want to not add the rotation to the scene component. So I'm going to delete that node. So we're only adding the local rotation to the drone mesh. Let's see what that looks like. We'll go ahead and press play. And we see that we're adding that local rotation to just the drone mesh, not the root component. That's that scene component. But we could go ahead and add a local rotation to both. I'm going to hit Control Z in here a couple times so that I can undo the deletion of that scene component because I'd like them both to call add local rotation. Now we'll be adding a local rotation to the scene and the drone mesh. Let's see what that looks like. Look at that. It looks like planetary behavior almost. And we don't have to add the same rotation to each one. We could simply be adding a yaw rotation to that scene component, and we could add, say, a pitch rotation to our drone mesh. Let's duplicate add local rotation. We have to hook drone mesh in for the target so it knows which component to add a rotation to. We have to connect the wires, and we have to give it a value. I'd like to change its pitch, so I'm going to take these two nodes. I'm going to duplicate them over here and hook them in for the pitch. And now we're rotating the scene component's yaw and the mesh component's pitch. Let's see what that looks like. Look at that. So we get different behavior depending on which component we're working with. So pretty interesting, right? So now that we know how to add a local rotation and a world rotation, we know how to use rotators. But we're actually not using rotators, are we? We're using float values. We're using scalars. And we saw that these functions do, in fact, take in rotators. So the last thing we're going to cover how to do is figuring out how to get this same exact result by passing a rotator in instead of just a scalar value. Now, to do that, I'm going to just delete the nodes where we're adding a local rotation to the drone mesh. We're just going to deal with the scene component here. And I'd like to add a local rotation by passing in a rotator and not a scalar. So I'm going to hold Alt and break that pin. And I'd like to recombine these pins back into that rotator input. And I can do that by right-clicking and choosing Recombine Struct Pin. That's going to recombine these back into delta rotation. But if we do that, we need a rotator to pass in. Well, we can make a rotator from float values. We can do that by right-clicking and searching for Make Rotator and using a Make Rotator node. This will make a rotator. It'll take the three values, roll, pitch, and yaw, and return a value with the rotator data type. So I want to make a rotator using this value that we had for the yaw. So I'm going to hook that in. And the roll and the pitch can be hard-coded to 0. And now I can take the return value and hook it into delta rotation. And now we're using this rotator value. And I can press play, and I can see it rotating, and it does as expected. So these make nodes exist for various data types. In fact, they exist for vectors as well. We can right-click, we can type make vector, and there's a make vector node, which takes in x, y, and z and returns a vector value. So we have more tools under our tool belt, and our tool belt is steadily increasing, which is very exciting. So excellent job learning about rotators and the difference between local and world when it comes to these offset and rotation functions. And of course, we'll be using those as we move forward. Great job. I'll see you soon.